Okay, today we are going to be looking at page 116 in your packet, integration of rational functions by partial fractions. And I'm going to start with number 12. Okay, number 12, it's unlike what we were doing yesterday, hopefully yesterday by the time you're seeing this, which is this part of it. Looks like we did 1 and 10. And we're going to be using some of these today, but here's the big difference here. When these exponents, notice a 2 is on the x in the numerator and a 3 is on the x in the denominator. When the numerator is higher, such as in the case of number 12, we have to handle it a little bit differently. So what we're going to do first is we want to simplify this by actually dividing the x cubed, the numerator, by the denominator, x squared minus 2x minus 8. Long division is how we do this. So we're going to take x cubed minus 7x squared plus 5x plus 40, and we're going to divide that by x squared minus 2x minus 8. If you have any terms missing, for instance, if there were not an x squared term underneath the division bar, I would have actually put a 0x squared there, and that's to have it as a placekeeper. Okay, then we ask ourselves, what do we multiply this by to get this? And we would need to multiply it by x. So above 5x, and it doesn't even matter where you put this, I just tend to follow the rules. Excuse me. As long as it's upstairs somewhere there. And then you multiply x times each of these. That's what goes underneath. And then we'll subtract. For x times x squared, we get x cubed. X times negative 2x, and we get negative 2x squared. And x times negative 8 is negative 8x. And we'll subtract. X cubed minus x cubed is 0, which is good. That's exactly what we want. A negative 7x squared minus a negative makes it positive 2x squared. So negative 7 and positive 2 gives me negative 5x squared. And then we have 5 minus a negative 8 would be 5 plus 8, and so we get plus 13x. And then we bring down the next term, plus 40. Now we ask ourselves, what do I multiply x squared by to get negative 5x squared? And that's a negative 5. So we'll put minus 5 up there. And then we do the same thing. We're going to multiply the negative 5 by each of the terms on the outside. So we have negative 5 times x squared is negative 5x squared. Negative 5 times negative 2x is positive 10x. And negative 5 times negative 8 is positive 40. And we subtract. Negative 5x squared minus a negative 5x squared is 0. 13 minus a positive 10x would be 3x. And then 40 minus 40 is 0. Okay, what's left down here is part of my remainder. So I'm going to put a plus right here. And the remainder is 3x over whatever you're dividing by. So it's x squared minus 2x minus 8. And that is now what we're going to integrate. So if we rewrite our integral as x minus 5 plus 3x over x squared minus 2x minus 8 dx. I've turned it into something that I can handle now. I can easily integrate x. I can easily integrate -5. And now my fraction, this rational function here, 3x over x squared minus 2x minus 8, has a degree on top that is lower than the degree on the bottom because it's x over x squared. All right, now we want to go ahead and integrate. The integral, well, actually before I integrate the x and the -5, I want to factor, I want to deal with my rational function. So I'm going to leave them out front here, and I'm going to go ahead and factor x squared minus 2x minus 8. We get x and x, factors of 8 that give me 2 are going to be 4 and 2. The negative goes with the 4, the positive with the 2. Okay, so now we get our zeros here as x equals 4 and -2. All right, if we use that, cover it up, let me go get my finger here from the previous page. Okay, so we're going to have two fractions. One's going to have an x minus 4 on the bottom, and one's going to have an x minus 2. Nope, plus. Make that a plus. Okay, so with the 4, I'm going to take my finger, I'm going to cover it up, plug in the 4, and we get 12 over 6, which is 2. Okay, and then next I want to use the -2, so let's cover up the -2 there, or the x plus 2. Plug in the -2, I get -6 on top and -6 on the bottom, so that's going to give me 1. All right, now we can just finish this up. When we integrate x, we get x squared over 2 minus 5x plus, leave the 2 out front, ln, absolute value of x minus 4, plus ln, absolute value of x plus 2. And don't forget your plus c. Okay, I'm going to leave number 11 up to you. By the way, if you remember synthetic division, on number 11 you can certainly use that. The 0 that goes on the outside here is going to be 1. And then 3 to -12 and 9. And you can divide it that way if you recall. If not, go ahead and use long division. All right, let's take a look at number 13. Okay, I had to go get my finger. All right, so let's, on 13, it says use the u substitution, u equals the square root of x plus 1 to evaluate the integral of dx over x square root of x plus 1. Okay, so what we should do here, excuse me, is I'm going to go ahead and find out what du is. So because this is x plus 1 to the 1/2 power, I'm going to bring the 1/2 power down, and then I'm going to, hold on a second, and then I'm going to leave the inside alone, reduce by 1, and then take the derivative of the inside, but that's just 1 dx. So that really turns into 1 over 2 square root of x plus 1 dx. All right, I like that because I can see this right here. And then all I have to do is solve for the x and substitute it in. Okay, so what we'll do is we'll get rid of the 2 on the bottom by multiplying it. So we get 2 du is 1 over the square root of x plus 1 dx. All right, next I need to solve for x. And so what I'm going to do is I'm going to take this u, which equals the square root of x plus 1. I'm going to solve for x by first squaring both sides. So I get u squared equals x plus 1. So that means x is going to be equal to u squared minus 1. All right, let's substitute and see what we find here. We've got the integral of, let's see, the 2 du. So I'm going to have a 2 on top. I like my du's off to the side. And then that takes care of that. And then I have an x on the bottom, so that's going to be the u squared minus 1. Okay, so let's factor this. It becomes u plus 1 times u minus 1 because it's a difference of squares. And so for my zeros on the bottom, I get u equals negative 1 and positive 1. So we have to do the cover-up. Let me go down a little bit. All right, so we're going to set these two up. U plus 1 is going to be underneath, and then u minus 1 will be underneath this one. And we're going to bring this guy to the front. All right, so let's start with the negative 1. If I plug in a negative 1, I get 2 over negative 1 minus 1 is negative 2. So I get a negative 1 here. And then for the next one, I get, let's see, I'm going to plug in a 1. So I get 2 over 1 plus 1 is 2, so that's going to be 1. All right, so I have ln, negative ln, absolute value of u plus 1 plus ln, absolute value of u minus 1. Now, I'm not done here. I have to go get u. Let's see, u is going to be the square root of x plus 1. Okay, so we need to plug that back in. Negative ln, absolute value of square root of x plus 1 plus 1 plus ln, absolute value of the square root of x plus 1 minus 1 plus c. And then one last thing that we can do is using the properties of logarithms, we can actually combine these two into one log. And that's going to be the natural log of anything with a plus goes on top, square root of x plus 1 minus 1, and anything with a negative out front of the logarithm gets to go on the bottom. So we have the square root of x plus 1 plus 1. And you can't do anything else with it. Please don't try to cancel things. All right, and that's the end of that one. And I'm going to let you try 14. And for 15, I want to show you how to do the trig function. All right, we've got use the substitution u equals sine x to evaluate the integral of cosine x over 2x times the quantity sine x minus 1. Okay, So I've got my u. I'm going to find my du. The derivative of sine, that's going to be cosine. Okay, I like that. That's right here. Here are some u's. So let's go ahead and try substituting and see what happens. All of this on top, the cosine x dx turns into du. So I'm going to go ahead and put that over here. And then sine x is going to become u. Sine x again, u minus 1. There's nothing on top, so I'm going to put my 1 up there. How nice. It's already factored for us. So we're going to use the zeros, 0 from the left side and positive 1 from the right factor. All right, one denominator is going to be u, plus the other denominator is u minus 1. All right, so let's plug in our 0. Cover that up. 1 over 0 minus 1 is negative 1. And then we'll plug in our 1. 1 over 1 is positive 1. We have the negative ln of, I'm going to go ahead and put my u in, that was sine x. Okay, absolute value of sine x. And then when I take the integral of the next one, I get ln absolute value of sine x minus 1. Plus c. And then again, using the properties of logarithms, we're going to turn it into 1 natural log, and sine x minus 1 is going to go on top because there's a plus in front of it. And then, because there's a minus in front of the ln of sine x, the sine x will go on the bottom, plus c. And there you have it. The rest of the worksheet is up to you.